again, Chapter 9 is about factoring. We learned to factor out a common monomial, and now we're going to look at, in these next couple lessons, some of the special cases that we had for multiplying polynomials. We're going to look at those special cases to factor them. And so this first thing we have here in the blue is to remember that x plus y times x minus y is always x squared minus y squared. And this right here we call a difference. We call a difference of squares. Difference of two squares, or just a difference of squares, because difference means subtraction and squares means squaring. So we have a difference of squares. So we learned that if we have x plus y times x minus y, it will be that difference of squares, x squared minus y squared. So we're going to review multiplying here. I'll multiply the first one out, but remember it fits this form right here. So this, we can multiply here. This would be x squared minus 7x plus 7x minus 49. We know that this adds together to be 0, so we're left with x squared minus 49, which fits our easy way up there to multiply that. Our second one fits this form also, so it's going to be the first thing squared. So 3x squared is 9x squared, and then we're going to subtract 4 squared, which is just 16. So if we multiply these two together, we would get 9x squared minus 16, which is another difference of squares. This is a perfect square minus another perfect square. Our last one again fits this form. The plus and minus are switched, but that's okay because we can multiply in any order. So it's going to be the first part squared, which that would be 49, x to the fourth, y squared, and then it would be minus 8 squared is 64, and then y squared is y squared. So that's multiplying them. Now we're going to factor. So we're kind of undoing our multiplication. So I have the rules still up there, but we're going to factor these. So we can think of this. This is my product. This is two things multiplied together. What did I have to multiply together to get x squared minus 64? Well, that's a perfect square minus a perfect square. And just to show you, remember this is x squared minus, and I can write this as 8 squared. And so that fits this form. And so therefore this is x plus 8 times x minus 8. We could check it. If we need to check, we have x squared minus 8x plus 8x minus 64. Oops, that was the minus 64. These become 0, and we have x squared minus 64. So this here would be our answer, x plus 8 times x minus 8. And so it fits that form. This next one here, this is a difference of squares. If we want to, we can write this as 2m squared minus 7 squared. And so it's easy to see this would be 2m plus 7 times 2m minus 7. Our last one, again, it's a binomial. And we want to factor this. We check, is this a perfect square? It is. That's 12 squared. And we check, is this a perfect square? Well, this is 11. 121 is 11 squared. X times x is x squared, and we want what squared gives me y to the fourth? Well, that would be y squared. So we could write it like this, and so again we see it fits this form up here, and so this is 12 plus 11 xy squared times 12 minus 11xy squared. So it fits the form, and so we can write it, we can factor it like that. So factoring the difference of two squares, I mentioned this last lesson that this is the thing we always want to do first, factor any common monomials out. And then we factor the difference of squares like we've been doing. And then we can check mentally, we can multiply. So looking here, first thing we want to do is see if we can factor out anything in common. Well, there's a 5 that goes into both of those. This has an a and this has an x, so that's not a common factor. Factoring out a 5, 5a squared divided by 5 is just a squared. 125x squared divided by 5 is 25x squared. And is what we did yesterday. That is what we learned in the last lesson. But now we want to see if we can factor further. We still have our 5 here, that's still a factor, but then we notice that this fits our special form, perfect square minus a perfect square, so this is a difference of squares, and so this is a plus 5x times a minus 5x, and that's factored completely. We don't want to just stop with this first thing that we wrote. We want to factor it completely, and this would be our answer. This next one has a part that throws people off because people forget that 1 is a perfect square. We could rewrite this if we wanted to as 1 squared minus 8y squared. And we realize that fits our special form. So we have 1 plus 8y times 1 minus 8y. So that's factoring a difference of squares. We see if we have anything in this form, and we then rewrite it. Now again, where this check mark is, always see if there's a common monomial factor.